So hello everyone. So in this session, we're going to start our classification algorithm that we have started previously, the naive Bayes classifier. So now what we'll do is we'll take emails and we'll build a classifier. So we have naive Bayes classifier that we have studied in the previous sessions. And we first discussed probability and then discussed about naive Bayes classifier. We took a toy example. After that, I told you that what we'll do is we'll take a real world example and then we'll code it. So the real world example that we'll take is we'll take emails and we'll build a spam filter. Okay. So what's the problem statement? Let me define the problem statement clearly. The problem statement is that you will be given emails. And you have to classify them as spam and no spam. You have to, and we have to classify them as spam or no spam. For no spam, they usually call it ham. Okay, and we'll use this naive Bayes classifier. So if you remember the pipeline that I taught you, about machine learning, like usually how algorithms are, the first step in there is you'll collect some data first. So you'll have the data collection, data gathering stage. And after you have data gathering, you now will have data cleaning and pre-processing. Okay. So you collect the data and then you process the data and you take feature engineering. You do a lot of stuff in here. And after that, you select a model. Which model do I need to select? Okay. And based on the assumptions of the data, you will select a model. After selecting the model, you will do model training. Okay. Then you will evaluate your model. These are the broad steps. I think we have a whole video dedicated to the pipeline of machine learning. I just give the important steps that are required there. So first we should gather the data, and after that we should clean the data and pre-process. And here in the data also I told you must understand data because you are not domain experts. Okay, so let's suppose some medical problem you are solving. You don't know medical, so for that you must visit domain expert and understand each of the features. What features affect what has the correlation. Okay, and we want to see that. And after that, you are the ones, when you understand the data properly, then you do the pre-processing and cleaning of the data. Sometimes there are missing values, there are duplicate entries, there are a lot of things that you can do. Okay, you try to understand the data also, and then you select the model. And sometime you will at least like you will spend your 70% time over here to understand the data properly. Okay, because that is what goes into your model. I have always said that garbage in, garbage out. So if your data is like garbage, so no matter how much complex, no matter how much great model you use, your output will be garbage. So it is better to feed really good data. So how to make the data good? So that's why you do data cleaning, you do data pre-processing, then you select a model. Okay, this is like easy part, and then you train the model and then you evaluate the model. That's the usually steps, and then maybe you deploy the model and keep on monitoring it continuously. But the point here is that you must first understand the data, and for that we have to gather the data. So here I have gathered the data from somewhere, so I have a data set with me. So from that data, if I have to analyze the data, I'll show you the data first, then we'll discuss the different techniques. So let me show you the data first. So here you can see that, so I have this data set. So I have loaded the data set. If you see by using the pandas, I have loaded the data set. These are the import statements. And then I had this spam ham data set. So now if I run these cells, so if you see the data over here, so this is the data that we have. Okay, this is the data that we have. So here we have a label is ham or it is ham or spam. So here this is the email. It consists of subject and the main message of the email. Then we have this label. So this is numerical label. So here label ham means like label number 0, and spam means label number 1. 1 means spam, 0 means no spam or ham. So here it's just named, indexed. Okay, so this is the data that looks like. So now I have to understand the data. Okay, the first I should get some information about the data. We had done exploited analysis at length. You have also got an assignment where you did a lot of exploited analysis. So I'll just see the basic information about data. How many entries do it has? How many columns does it have? Something like that. So this is the thing that we'll be doing. So print data info. Data.info is a function. Okay, you can just call this function, and here you can clearly see that the information data. This is a pandas data frame. Okay, and then there are 5171 entries. That means these many data points are there. Okay, and we have these many columns. We have 4 columns. So here this is unnamed is some variable, and label is there, text is there, label number is there. Okay, you got the brief overview of the data set. Okay, how the data looks like. Then what I want to see is, I also want to see, okay, how many these spam emails are there, how many non-spam emails, emails. I also want to get an idea of that. Okay, so then you can just see over here. You can plot this figure of this count plot, basically sort of histogram, and then you will see how many spams are there. So if you want to understand this code, it just takes data and counts this and counts the number of spam and ham. And here, if you just run this line of code, so you'll get a plot like this. And you see that there are around 3600 ham emails, 3672 spam emails are 1499. That's what I have also written here. Data of labels value counts. This gives me basically the count of the labels. Ham labels are 3672 and spam emails are 1499. So this is a pretty imbalanced data set. Now you got, there is the imbalanced data set, and we have learned techniques how to deal with imbalance. And okay, and then we'll also see something. We'll see, okay, we want to see the length of emails. Okay, if there is a spam email, is there a correlation between length? Let's suppose you write an email, if it's huge, very huge, that probably means it is spam or something. Okay, so we'll also use this data text and we'll apply this length function over all the fields of this text, and we'll see what is the length, and then we'll plot the distributions. Okay, if we plot it again, so you will see the distribution like this. Okay, so maybe sometimes you can infer some results out of this, sometimes you may not infer. So this is just an understanding you have to the data. So my point being here is, so whenever you are dealing with a problem, the first point that you should be doing is you should be doing the analysis of the data. That's what you should understand the data. So now you have data and try to understand it. Okay, try to understand this data. Now we understood the data somehow. So our data has the main two features that in the data are label, and we have an email text. Now you know that I cannot feed directly this email because it's written in English. I cannot feed directly to my algorithm, because if you saw, you need some numbers in there. Okay, because that's what our machines understand. They understand numbers. So I have to convert this email into some vector. Okay, that's my job, because I have to feed this into the thing. Because now I understood data. I thought, okay, there are labels. I can just use 1 and 0. I can use 0 for ham, basically no spam, and 1 for the spam. But here email is bunch of words, bunch of sentences. So how can I vectorize it? Basically we call it embedding also. Okay, how to convert an email, or how to convert a sentence, how to convert a document into a vector. Okay, this itself is a job in itself. Okay, this comes in data, and that you will feed that vector, then you will feed into your maybe algorithm, whatever naive based algorithm will be doing. I hope this is clear till this point. Okay, now why do we want to do it? Okay, why do we want to convert this email into the vector? The first thing is because machines, they work on numbers, so you have to give numbers so a machine understand these numbers. Okay, so the first reason I say that machines do understand these numbers. Machines understand numbers. So you have to convert this English somehow into some number so that you can feed this into some machine learning algorithm. Okay, and then you can also make a vector out of it. Why do you want to make a vector out of it? I said that most of the machine learning techniques, they use algebra, linear algebra. Let me take a simple example. Let's suppose you have an email. Now if you somehow convert this email into a d-dimensional vector, let's suppose we have a vector d cross 1 vector we converted. Okay, and then if you see those emails in that dimensions. Okay, let's suppose the emails will be like this. Some spam emails will be somewhere like around this. Okay, and then your no spam emails will be like this. Okay, you will see them, they are getting clubbed together in their data, and maybe this can happen that they are becoming linearly separable. We have had a discussion on linear separation. So maybe you have a hyperplane that can separate. This is in d dimensions, but we cannot imagine beyond 3 dimensions. So that's what I just wrote it in 2 dimensions. But think that this data basically is in some higher dimension. Okay, in higher dimension there is some hyperplane which is separating it. So you know that this plane can be represented by W transpose X. Okay, if it's going through origin. So to be specific, this can be represented by W transpose X plus B. Okay, so then we say, let's suppose if we remove this bias also, so we can say if W transpose X is greater than 0, so this is, let's suppose, positive class, or maybe spam or something. So W transpose X is less than 0, so this means if it is because we have W here, so if it is greater than 0, so this is, let's suppose, no spam. So then this is no spam. And if it is here, this means this negative class, this is spam. We call it ham also, so I write ham. Okay, that is one of the advantages we have. So we want email, we want to project it, or projection is not the right word, we want to get an d-dimensional representation of the same email. Okay, what should be unique about the representation? The unique representation should be, let's suppose I have email 1 and I have email 2. So this is email 1, email 2, and email 3. I have these 3 emails. So my representation of these emails should be such so that if email 1 and email 2 are somewhat grammatically similar or English wise they are similar. Okay, let's suppose I have my birthday and I'll receive a lot of emails on my birthday. So there somebody says happy birthday to you, somebody says some congratulations on this and that. And maybe these emails are similar. Let's suppose E1 is somewhat similar to E2. Okay, and E3 is some other email. So how I want my embedding to be? I want my embedding to be like this. So distance of this E1 comma E2 should be less than distance between E1 and E3. Why is so? Because similarity of E1 and E2 is more than similarity between E1 and E3. Okay, this is my point. So my point being, if two things are similar, okay, listen to the principle. The principle is that whenever you're encoding something, so you will have things like which are similar, which are English wise they are similar. Let's suppose we have this food is tasty, this food is delicious. Both of them have same meanings. When I'm creating an embedding, my embedding should be such that the distance measure, if I measure the distance between them, so we have also had chance to discuss different types of distance like Euclidean distances, Manhattan distance, a lot of distances we covered. So distance in that, when we compute distance between this E1 and E2 which are similar should be less than distance between E1 and E2, because this is dissimilar to E1 and E2 are not having less similarity. That's my principle, which should be my guiding principle. Okay, so the problem that we are basically handling is we have an email, we have to say whether it's a spam or it is a ham. It is a spam or no spam email. But now we got stuck into a problem. These emails basically are English sentences. Okay, they are just bunch of words. Now the point is how to convert that into this. Okay, now we followed a principle. We said, okay, the principle is that if there is English similarity, if there is language similarity, I'll say, if two things are similar in the language, when I'm converting them into a vector, when I'm converting them into numbers, the distance should be less. Okay, against those, if there are two dissimilar things, if I'm making an embedding or I'm making a vector out of that, the distance should be more. Okay, how many of you understood the principle? Again, getting you back to the picture that we are solving. So we have to make a classifier. So we have to detect if email is spam or if it is ham. This is what I would have to classify. We collected some data and we try to understand data. So the two important fields that we saw were our emails and our labels. These were two important things that we said. So for emails, we had direct number 0 or 1. 0 means it is ham and 1 means it's spam. For emails, these were English sentences. Okay, these are just English sentences, and I wanted to convert these words and sentences into some vectors so that I can feed this into some algorithm. But I made a principle for myself. I said, okay, the one thing that I should ensure is that when I'm making these vectors, it should be such that if I make a d-dimensional vector out of these, so for similar emails or for similar words, the vector should be somewhat similar. Okay, the distance should be very less. When I compute the distance, maybe Euclidean distance or some Manhattan distance, if I just compute the distance, that distance should be basically less. That was my guiding principle. Okay, now let me introduce some terminology, so that because I'll be using this terminology quite often, so you have to understand this. Now I will not be saying emails because in natural language processing they are not said emails. So okay, I'll introduce some terminologies, but do not get lost in this micro study. Have that big picture into your head what we are solving. I just want to introduce the terminology because I will be frequently using them. Okay, so now I have a bunch of emails. I won't call I have a bunch of emails. In natural language processing, we call it a corpus. Okay, what is corpus? Corpus is a large collection of text or transcribed speech. Let's suppose if you have text or if you have some speech which is transcribed, which is written somewhere. Okay, and you have a lot of these. And let's suppose each of this email, let's suppose if I have a bunch of emails, email 1, email 2 till email 100. Whole of this set will be called as corpus. Okay, so corpus is a large collection of text or transcribed speech. Okay, so here corpora can be monolingual or contain the text of single language. So in multilingual, which contain multiple language. So here just keep in mind that this corpus means set of these documents. Now I again introduced a word document. So in natural language processing, we call each email a document. We don't call it an email because we have, let's suppose today you are working with emails. Next time you'll be working with some reviews. Next time you'll be working with some reports, English reports. So all of these will be called documents. So set of documents is called corpus. So what is a document? So in the context of natural language processing, a document refers to a single unit of text data. Okay, unit of text data. Okay, this is collection of documents. This is collection of documents. So here each email is a document because that's our one unit of text. In let's suppose sentiment analysis, if you are having some reviews and you want to see it's a positive or negative review, so there each review is a document. Okay, I hope this is clear. Then there is another term called as, it itself is called term. Okay, so term means which is a meaningful word or a phrase. Let's suppose in the context of our emails, one word is called as one term. Okay, one word, a term is meaningful, it should be meaningful, or it can be a phrase also. Okay, let's suppose machine learning, natural language processing, these are terms. Okay, I'll say a meaningful word or a phrase. This is called as term. Then we have something called as token. Okay, token is a single unit of text. Okay, a term can be a token also sometimes, but you can tokenize differently. Let's suppose you have forever. Forever can be one term, but if you break it in between for and ever, if you make it separate, so you tokenize it separate. You might have heard about tokenization. Token, how do you break the sentence? Token means one single unit. It may not be meaningful also. It can be without the meaning. For humans, it may have no meaning. Okay, so it's a single unit. A single unit of text. Okay, it may not be meaningful, but token, this term usually is meaningful. Let's suppose you are talking about machine learning, natural language processing. These are terms which have some meaning to you. But token, I can say for is a token. I can say th is a token. Okay, I can say only t is a token. Okay, token is how basically you break down the things. Okay, this is if you have a large sentence and now you try to break, you said that I'll break this after each word, then that word is also a term, but that's also a token. So tokenization is the process of separating these words. So here there is a term tokenization. So tokenization basically tells you how do you break these things. Okay, how do you separate this text into tokens. Okay, a small unit, a single unit is called a token. It may not be having any meaning. Okay, then we have something called as vocabulary. Vocabulary. Vocabulary basically tells you collection of unique terms. So you have collection of all the unique terms present in the corpus. Okay, let's suppose if you have a 100 documents, you will collect all the words there. So that will make your vocabulary. Let's suppose in English, sometimes you say how much rich is your vocabulary. So that means how much words do you know. So all the English words are called, they are summed up in a dictionary. So we'll call that a vocabulary of English. Okay, a vocabulary basically means collection of unique terms or words. Okay, words basically mean, term basically meant which has some meaning present in the corpus. Okay, so again going back to these terminologies, because I'll be using this instead of these emails and these reviews, I'll be using these things. Corpus basically means the set of all documents that you have. It may be documents of emails. You might have bunch of emails, you'll call that a corpus. It may be document of reviews. It may be you may have medical test data or something like that. All of these things combined are called a corpus. What is a document? A document is a single unit of text data. Okay, let's say one email, one review, or one medical report, that will be a document. What is a term? A meaningful word in that or a meaningful phrase in that is a term. Let's suppose machine learning was discussed. In the email there can be something buy, free, dare, hello, something like these are terms. Then token. Token is the single unit of text. It may be without meaning. So from that we have a process called tokenization. So tokenization is a process of breaking down the text. Let's suppose you have text and you want to tokenize it. So it depends on you how you tokenize it. You can just have a token of single letter also. You can have tokens of two letters also. That depends on you. Then we have vocabulary. Vocabulary basically means collection of all unique words or terms. So in terms of English, so all the English words that exist there in the world which have meaning, that's called vocabulary. Okay, I hope that these terms are clear to you. So can I assume that these terms are clear? Now having these terms, now you understood all these terms. Now we'll see how can I convert these emails, or how can I convert these documents into a vector. So now I have to convert these documents into vectors. Now in literature there are a lot of techniques that have been discussed. So okay, so there is something called as bag of words. Okay, and then we'll see something called as TF-IDF. term frequency, inverse document frequency. Then there is something called as word to vec. Okay, and there are a lot of other techniques also. So we'll mostly learn all the technique, because the first step, do not lose the big picture. The big picture is we are trying to make a classifier which will take emails as input, and then it will output if it's a spam or not spam email. So for that, we first have to represent that email somehow into the vector form. The first technique that we'll learn is this bag of words. Please focus over here. Bag of words. This is the first technique that we'll learn. So what's the meaning of this bag of words? Again, you can say this is the technique by which you basically convert a email or a document, whatever you have, basically I'll tell document, into a vector. So what's the method of converting this? So how does it work? So let's suppose it will take a document, we'll call it D. So it will have words like this: W1, W2, W3, W4, W1 again repeated something, W2 can be repeated, W6 something like this. Then you have, this is document 1. Then we have document 2. This can have words like W3, W2, W4, W8, W10, W11 something like this. Then I have document 4. W9, W10, W1, W4, W3, W2 something like this. Okay, sentence can be let's suppose the cat is sitting on the mat. The is one W word, this is W1, then cat is another word, mat is another word. Okay, there can be words, and then can be repetitions also. The first thing that you do is you construct a vocabulary here. That's the first thing. You create a vocabulary. So we'll call it vocabulary creation. So what is that? So that basically is you will take all the unique words that are present in whole corpus. So you'll take this whole corpus and you will see what is the vocabulary of that, how many unique words are present there. So each word is assigned some index. So now you'll have a vocabulary, you'll have a list of words. Okay, let's suppose you will have a corpus. From this corpus, if you see W1, W2, W3, W4, W6 and W8, W10, 11, 9. Okay, these are the unique words. So you'll put it like this: W1, W2, W3, W4, and W5 is not there, W6 we have, and W8, W10, W11, W9 is also there. Okay, and these are the unique words. This is our vocabulary. So this is the first step. So what you will do is, because now you want to create a vector representation of a document. So what I'm telling you, the first step over there is, this is the step 1. So step 1 is that you create a vocabulary. Okay, now you have the vocabulary with you have all of these words. Okay, you have this vocabulary, and the second step is, now for each document you will have to create a vector of this. So you will create a bag of vector words. So for document 1 it will be like this. So because now this is W1, W2, W3, W4, W6, W8, W10, W and W9. This is all the words. Now you will say W1 it appeared 1 times. It appeared 1 and 2 times over here. So you will write 2 here, over here. Okay, this corresponds to W1. Then W2 it's 1 times. It's also 2 times, I think. 1 and 2. So this is also 2 times. Then you will see W3. W3 is present 1 times over here. So you will write 1. Okay. Then W4. This is W5 also. So I think this is W4. I wrote W4. Let's suppose this is W4. This is W1. W1, huh? So over here, if you see now, so W4 we have it. W3 is 1 time, W4 is 1 time, and W6. So this is 1 times. W4 is 1 times. W5 0 times. W6 is 1 time, because W5 we don't have even in the vocabulary, so we need not to write 0 over here. So W6 is 1 times, and then 0 0 0 0. Then there is no word like this. Okay, so this is the vector representation if you see like this. And then similarly you can convert D2, and basically what you are seeing is, you are seeing, okay, W1 is W1 there? No, so it will be 0. Is W2 there? Yes, W2 is 1 times there, so you'll write 1. So is W3 there? It is not there, so you'll write 0. Is W4 there? Yes, 1 times. W6 is it there? No. W8 is there? Yes, 1 times. W10, W11 and 0. So this is the vector representation of D2. Okay, so first step is, step 1 was to create vocabulary. Step 1, vocabulary creation. In vocabulary you see the whole corpus and you basically get the whole unique words out of that. The step 2 was, for each document now you are writing a numerical number. So for each document in the corpus, it is then represented as a numerical vector, where the length of the vector is equal to the size of vocabulary. So this length is equal to size of vocabulary, and each of this entry, if you ask me what is each value of the dimension, is a vector corresponding to the frequency. So here it says frequency of that word into the document which we are concerning about. So let's suppose you are taking D1. So if the entry here means this word appeared these many times in the document. This is whole about this. This is the whole about bag of words. How many of you understood bag of words?
Yes, sir.
So you understood bag of words. Asrar? Now you can see this is a representation. Now let's take an example. So I'll take an example. I'll have sentence 1 or maybe document 1 is the cat sat on the mat. The cat sat on the mat. Okay, let's suppose my document 2 is the dog chased the cat. The dog chased the cat. My point is that I have to create vector representations of D1 and D2. So I said, what is bag of words? So in bag of words, what will I do? I'll first do, I'll create vocabulary. So in the vocabulary, there will be there is cat, there is sat, there is on, okay, there is mat, there is dog, chased. I don't think I missed any word. Okay, this is my vocabulary. I hope this is the same, dog chased. Yeah, this is my vocabulary. Now for D1, I will have to create this. So for D1, what is the vector corresponding to D1? Bag of words vector basically. If you see this, the 1 and 2, it appears 2 times in here. Cat, it appeared 1 time. Sat also 1 time. On 1 time. Okay. Mat 1 time. Dog 0 times and chase 0 times. So this is the vector representation of D1. So for D2, it will be something like this. So the appeared 1 and 2 times. Cat appeared 0 times. Sat appeared 0 times. On appeared 0 times. Mat appeared 0 times. And we have the cat, then we have mat, dog. I think dog appeared 1 time and chased appeared 1 time. Okay, I think this is the representation of this. So the cat sat on mat appeared also. Yes. So this is the representation of these two vectors. If you see it. So this is all bag of vectors does. This bag of words, it does. So this is one of the techniques. Now what are the limitation of this technique? So there are limitations to this technique. The point was you converted maybe a document, it can be an email, it can be any English sentence. You basically convert into some vector format. So this was one of the easiest way that we could think of. Okay. So even you can have binary bag of words. There is something called as binary bag of words. Before talking limitations, there is a small concept, binary bag of words, which says you just write absence or presence of the words. You don't write the frequency. You just write if it's absent or present. So 1 and 0. So 1 means present, 0 means absent. And one more thing it is, so bag of words, you just write 0 or 1, present or absent. You don't write the frequency. You just write absence, presence. So what is the limitation of this? The first limitation, I will say that this is sparse. So if we have d-dimensional vectors, you know that if we take a sentence, vocabulary is way greater than the number of words. If we have, let's suppose, 1,000 documents, in 1,000 documents there will be 10,000 unique words. So but for each the document, if the length of total length is 200 words or something, so most of the entries will be 0. So sparsity. Okay, you are making a vector that is sparse. It's very sparse. Okay, and then you have to take care of that sparsity also. Basically, all these 0 do not contain any information. That is one of the limitations that we have. We are creating sparse vectors out of this. And the second limitation is that now the word order is lost. Okay, so there is no respect for word order. No word order. Now, if you see, the cat sat on the mat. Okay, and the mat sat on the cat. These are two different sentences. This sentence is somewhat like different, this is somewhat different, but in bag of words, as the order doesn't matter, the word order doesn't matter, but in you know that in natural language processing, word order does matter. So now this also has this limitation that their word order does not matter, that you can see clearly from this example. This D1 and D2 will have similar vector. They'll have distance 0. So from the perspective of bag of words, they are same, but they are not same actually. Okay, that's where limitation. So our first step was we had to basically find vector representation of these documents. Now we said, okay, let's come up with a simple technique. One technique was bag of words. That was simpler. And now we are trying to see what are the limitations and can we somehow then overcome these limitations. So one is sparsity, that the vector made it's very sparse because vocabulary usually is very high. Okay, and we have this high dimensional vector, but most of the entries are 0. And then second thing is loss of this word order. So word order is lost, but not because you know that in actual language, in our natural language, this word order matters. So if you just reverse the order, it means somewhat different. So here you said the cat sat on the mat. The mat sat on the cat. It has some different meaning. Or even you can say Ram killed, let's suppose Sham. Sham killed Ram. Entirely different meaning. Okay, and from the perspective of bag of words, these both might have the similar meaning. Not even might have, they will have the similar word vector representations. Okay, and one more limitation that I can think of from this bag of words is loss of semantic relationships. Okay, what I mean by that is, I'll write it, loss of semantic relationships. So what's the meaning of this? So this means that, let's suppose if I take car and automobile, so they both mean the same thing, but they are separate entities, they'll be treated separately. So the semantic relationships are not taken care of in this bag of words. Okay, so in bag of word model, each unique word in the vocabulary, if you have that, it is assigned a number, it is assigned a frequency. Okay, it fails to capture any semantic relationship between words, like synonyms, antonyms can be there, or some other word associations can be there. Like for example, car, automobile is a synonym, delicious, tasty is a synonym. So there is no way to capture this by using this bag of words. Okay, that's what I mean. That's what I mean by loss of semantic relationships. So by semantic relationship, I mean synonym, antonyms, or other word associations can be there. So I'll write it synonyms, comma antonyms, comma some other word relations. It doesn't take care of these things. Now I'm building a method. It gives me a vector representation, but now I'm finding some limitation, and based on that, we'll build slowly and slowly. Then again, one more limitation that I can write is it is not able to handle what is called as polysemy. Not able to handle polysemy. So what is the meaning of this polysemy? Polysemy basically it refers to the words having multiple meanings depending on the context. Okay, let's suppose you have same word, and depending on the context, it will have different meanings. Okay, cool. Let's take word cool. Cool basically, if you take in one context, this is looking cool. Okay, and sometimes this weather is cool, so it has different meanings. So same word, when used in different contexts, it has different meanings. So it does not care about these words, so not able to handle this polysemy. So if a similar word is used in different contexts, it changes the meaning, but here you see that it doesn't care about that also. Okay, one more thing that I can write is it does not care about that's called as morphological variants. Morphological variants, you don't need to even remember these terms, but I just wanted you to give the gist. Okay, why does it fail? Because we come up with a technique and that has problems. So what is this morphological variant? If you, let's suppose, see a word run, word ran, and running, they basically came from same embedding. So they basically came from the same root word, that's basically run. So all of these somewhat mean the similar thing. Okay, and this bag of word treats them entirely different words. Okay, it doesn't care maybe the root word is same, they have a similar meaning. The morphological variant, it lacks to handle that. Okay, the bag of words treats different morphological form as the same. Okay, you see this run, running, ran, it contains it says these are separate entities. Okay, because it fails to capture the underlying semantic similarity. These are limitations, and there will be much more limitations than that. So my point was, okay, I have a vector, I have an email, I have a document, I want to convert it into a vector. Now I gave a simplest technique, bag of words, then I see the limitations. Okay, before moving ahead, so we'll first see how to code this, how to code basically this technique. Okay, so here we'll code the technique. So if you could see this, so this is our corpus. So I have this, the cat sat on the mat, the dog chases the cat, the sun is shining, the weather is beautiful today, the sky is blue. So each of this is my one document. So this is my document 1, this is my document 2, similar, this is my document 3, document 4, something like that. The whole of this is called corpus. That's why I called it a corpus. The first step was to create a vocabulary. So how to create this vocabulary? Vocabulary should have unique words. That's why I introduced the set over here. I said vocabulary should have unique words, because you know that set data type in the Python, it contains only unique entries. Now what will I say? I'll take for sentences in corpus, I'll go through the whole list of corpus. I'll take the sentence of the corpus. Then I'll say words is equal sentence lower split. I'll split these words and also convert them to lower, because this the and this the will be treated differently otherwise. That's why I'm converting them into lowercase first. So I'm taking all the sentences. First I'm taking this sentence. I am making all the words as lowercase, then I'm splitting and putting them in the vocabulary, and then I am writing vocabulary dot update words. Okay, so I am putting those words into this vocabulary. That's the first step. Okay, so I am taking all of the unique words from this corpus and creating this. And the second thing, I'm sorting it also. Okay, so this is not even a step also. So sort, you can sort, and you may not choose to sort. Okay, I have sorted this over here. So this is the second. This is the like first step, and this is optional step, this sorting. Then if you see, the second step is now creating a representation. So now I am saying this bag of words representation. For each sentence, I'll have to create it. That's why I'm running a loop for each sentence. Okay, so I'm saying bow representation is 0 multiplied by length of vocabulary, because you know for each document the length of the vector will be equal to the length of vocabulary. That's why I'm initializing everything with 0. Okay, now I'll fill these entries. This is my words. Words is equal sentence or lower. Again, I'm converting everything into lower, and I'm saying for word into words. Okay, for all the words that are in sentences. If word is in vocabulary, okay, if that word is in vocabulary, whatever vocabulary I have created just now, if the word that I have picked from the sentence, if it's that in the vocabulary, so put an index over there. Okay, word index is equal to vocabulary index and word, and just go to that index, because I have a vector like this, I'll have a vector like this. Okay, so now I'll go to the index and I'll just increment it by 1 counter. So if I found a word, I'll just find the index of that in the vocabulary. And because now as I have sorted this, so this is bow representation of word, so I'll take this vector and just increment it by 1. Okay, and at the end I'll have this bow representation. This will basically contain all the bow representation of all the words. Okay, so this is my second step, step 2. If you see this again, so initially I'm going through all the sentences, converting all the sentence into lowercase first, then taking each word from the sentence and seeing where it is present in the vocabulary, just increment it. If it is not, then it will be 0, because that's how I'm initializing this. Now I'm printing this. I'm printing the bow representation, and this is my representation. So if I just run this cell over here, so you can see for sentence 1, this is the representation. This is my first, this is my vocabulary. And animals are beautiful, blue cat, this is my vocabulary. And sentence 1 is represented like this, sentence 2 like this. Okay, and now you are seeing that most of the entries are 0. This is sparse vector, the limitation that I said. Okay, this is the limitation I told you, that we have a lot of zeros will be there. So that is evident from here. Okay, this is the simplest technique that we started with, is called as bag of words. I hope that this technique is clear, and we will slowly advance, go towards different techniques which are way advanced than them, and which somehow will try to figure out how to overcome these limitations. And then we'll go on something called as TF-IDF, then we'll go on word to vector, and finally we'll use a word to vector for our classifier, because the whole point of this teaching you this is because you have an email, you have a document, you want to convert it into vector. That's the first step. I hope this is clear. So I'll stop the recording. If you have any questions, I'll take that.